So there's nothing special about finding the derivative of an inverse function because we already know how to find the derivatives of all sorts of types of functions. So what I really wanted to point out here is, let's say I give you f of x equals x cubed plus 1. Well, I want you to find the inverse of that, and I also want you to find the derivative of that, and I want you to find the derivative of the inverse. So obviously the inverse is the hardest of the three. So I would start with y equals x cubed plus 1. I would then say, okay, I got to switch those around. So x equals y cubed plus 1. So x minus 1 is y cubed. So the cubed root of x minus 1 is equal to y. So that's the inverse function. And that's really the hardest work that you'll have to do. Then I'm just finding the derivative of each of those. So the derivative of my first function here, real easy, 3x squared plus 0, so 3x squared. And then the inverse of this guy, remember I would think of this as x minus 1 to the 1/3. And so then I would use my rules to find the derivative of that. And that would give me this function right here. Obviously it would start out as 1/3 x minus 1 to the negative 2/3 and then rewrite it. So I have found all of these things that I was asked to find. And I want you to notice I've just given you some values of the derivatives of each function. So f inverse, I gave you some values. So this is from the original function. And then the derivative at 1 was 3. The derivative at 2 was 12. The derivative at 3 was 27. Then I want you to notice if I look at the g of x function, obviously we already knew that this relationship would happen where 1, 2 is now 2, 1, that 2, 9 is now 9, 2. But I want you to notice what happens with the values of the inverse derivative. So notice the values of the inverse derivative are 3 1/3, so the reciprocal, 12 and 1/12, 27 and 1/27. So we can see that relationship that the derivatives of the inverses are essentially reciprocals of one another. So essentially what we're saying is this, that if I want to find g prime of x, it's going to be equivalent to 1 divided by f prime g of x. Now you might be thinking, well, where did that come from? That feels like it came out of nowhere. Well, we know because these functions are inverses that f of g of x is going to be equal to x. That's given to us. How do I know that? Because they're inverses. That's the definition of an inverse. So g is going to map x to some number. That some number is going to map that number back to x. That's what inverses do. Now what I want to do is think about, what if I took the derivative of this? Well, this is just chain rule. So f prime of g of x, I'm going to just take the derivative of each side. So derivative of this side, derivative of this side. So the derivative of the left side gives me f prime of the original, and then chain rule says now take g prime. On the right side, the derivative of x is just 1, and I can see from here that if I'm trying to get this by itself, then I get g prime of x equals 1 divided by f prime of g of x. So that's where this comes from, is just deriving the composition of an inverse function. Now what I want to do is take a look at an example of this. When might we use this? So now let's take a look at an application of this. Here I've given you a function f of x, and I said, hey, guess what? F of 2 happens to be 3, just nice enough to give you that number. So now what I'm asking you to do is two things. What's the value of f inverse of x when x is 3? Well, because I know that 2 comma 3 is a point in my original function, then I know the point 3 comma 2 is a point in my inverse function. So since f of 2 equals 3, we know f inverse of 3 is equal to 2. That's pretty straightforward. That has nothing to do with that little equation that we just went through. This has to do with being an inverse. Now I'm asking you the harder question. What is the value of f inverse prime, so the derivative of the inverse of x? So I could find the inverse and then derive it, but that's going to be difficult because if I'm trying to find the inverse of this function, that's not fun because I've got an x cubed and that's going to be a lot of work and I don't want to do work. So what I can do is use that little function that I just showed you a few moments ago that said if I want to take f inverse of some number, then I'm going to find, and I just used it with g and f before, but really it's the same thing. If I want to find g prime of x, which is the same as f inverse because we're calling g the inverse, then I'm going to take 1 divided by f prime of g of x. So that's what I'm going to do now, is take f prime of g of x, but here we're specifically using 3. So let's take a look at that. I'm trying to find 1 over f prime of g of x, and g of x, again, is the same as the inverse of x, of f. And so that's this guy, right? So if I said, what's f inverse of 3, well, I already answered that question. F inverse of 3 is 2 because they told me that at the beginning. So now I'm just finding 1 divided by f prime of 2. Well, taking the derivative of this is a heck of a lot easier than trying to find the inverse. So the derivative is 3/4 x squared plus 1. That's f prime of x. And so all I'm going to do now is take f prime of x and plug in 2, so 2 coming from back to where I started. And that's pretty straightforward. 1 over 3 plus 1, and then I get 1/4. So instead of having to take the inverse of a function that would be really hard to take the inverse of, I'm able to work through it in this method instead.